Hello and welcome to this IB Maths Intense session on sequences and series. This is the first in a set of videos introducing and then expanding on this topic. It's an important topic in the area of number and algebra, and you'll see that it appears in many places on our syllabus. So SL 1.2 talks about arithmetic sequences and series, SL 1.3 geometric sequences and series. It appears in SL 1.4, talking about the financial applications of what we've learned with geometric sequences, and then in SL 1.8, where we're looking at infinite geometric sequences. So it's a big topic, well worth mastering, and it's equally valid for both standard level and higher level students. So pretty well everything you see in this set of videos on sequences and series will apply to both sets of students. So to start with then, just general introduction, what do we mean when we talk about a sequence? This shouldn't be too difficult for any of you because you will have seen plenty of sequences during your maths career to date. Here are four nice easy examples. 2, 4, 6, 8, 10 is a sequence of numbers that goes up by 2 every time, starting with the number 2. It's the 2 times table. The second one, 1, 4, 9, 16, 25, hopefully you recognise that straight away as the squared number sequence. So the third term is 3 squared, 9. The third sequence there, 1, 3, 6, 10, 15. Well, this is slightly different because the difference between the terms goes up by 1 every time. It goes from 2 to 3 to 4 to 5. It's the triangular number sequence. So 1, 3, 6, 10, 15. The next term would be 21 because the difference between the terms would have to be 6. And then the fourth sequence there starts with 200, and each term is just half of the previous term. Now they all share something in common, which is they're all lists of numbers in a particular order, and they have a well-defined set of mathematical rules for us to determine the next term in the sequence. And that's what makes them a mathematical sequence. And for notation, we will use u with a little n on the bottom to specify the nth term in a sequence. So in that first sequence, for example, u3 would be equal to 6. And un is our general descriptor for the nth term. Also very important in every sequence will be to know u1, which is the first term, but we'll often give this its own label, which is A. So you might see in the formulae and in the examples we show that the first term has got its own recognisable symbol, which is A. What about rules for sequences? Well, there are two different ways in which we can define rules. The first rules are called recursive rules or recursive definitions, often called term-to-term rules. And this is where a sequence is defined based on the next term and its relationship with the previous term, hence term to term. So in the first sequence here, we'd have a rule that says un plus 1, in other words, the next term in the sequence, is equal to un, the previous term. The relationship between un and un plus 1 is they're next to each other, and it would be un plus 2. And that tells me this is a sequence that goes up by 2 every time. However, it's a little bit useless unless I know what my first term is. So u1 is equal to 2. Now I've got enough information to build up this sequence from the start. The second one, a little bit more difficult, but again, I can say that the next term, un plus 1, is always equal to half of the previous term. So un plus 1 is always equal to half of un. And again, I need to know the first term in order to be able to write this sequence. Otherwise, I don't know where to start. So those are term-to-term rules, but I think you'll agree they're a little bit unwieldy because I need to know the first term and I have to build up the sequence from the start. So if I wanted the 37th term, it would be a bit painful having to write the first 36 terms to get there. So we have a second rule or type of rule, which is called a deductive definition, often called a position-to-term rule. And this has the advantage that we can go straight to a particular term based on its position in the sequence. And this is probably a more common and more useful way of defining the rule. So in the first one, our rule would just be un equals 2n. In other words, I take the position in the sequence, so say the third term would be calculated by 2 times 3. N is the position, so 2 times 3 is 6. So u3 would be equal to 2 times 3, which is equal to 6. So I can go straight there. So if I wanted to work out the 37th term here, that would be much easier. u37 is 2 times 37, which equals 74. The second sequence, again, I can define that as a position to term rule by saying that un is equal to, well, I am taking my first term 200, and each time I'm multiplying it by half to the power of n minus 1. So for example, the third term is 200 times a half to the power of 3 minus 1, which is a half squared, which is a quarter. So 200 times a quarter is equal to 50. That's much more useful and more commonplace when we're working with sequences. The word series also appears alongside sequences and series. But it's important to know what the difference is. So whereas the sequence is the whole list in a particular order, a series is just the sum of certain part of the sequence up to a certain point. So in the first case, instead of thinking of the sequence as 2, 4, 6, 8, 10, I can think of a series of the first 5 terms, 2 plus 4 plus 6 plus 8 plus 10. So the sum of the sequence of the first 5 terms is called a series, and it equals 30. And I have a particular notation for writing this. I could say sigma, this is my maths notation for the sum of. And I can say n equals 1 to 5. That's telling me I'm interested in the sum of the first 5 terms in the sequence. And then I would specify my rule, which I had before, which was 2n. And the answer there is 30. Sigma n equals 1 to 5, 2n is equal to 30. And the second one, likewise, notice I'm using the position to term rule here as the rule that is in the notation there. I'm not using the term to term rule. Second one, n equals 1 to 5, and the rule this time was we had 200 times a half to the n minus 1, and that's the rule. And if I add those terms together, I get 387.5. This is sigma notation. It's very important that you understand how it works. So in general, we'll have something that says sigma, the sum of, and then we might have, I'm going to use r here, r equals 1 up to r equals some other point, maybe n, and then I'm going to have the function, or whatever it is the rule is, after that. And that's a general form for functions notation, so for sigma notation. So for example, I might have, like we had before, sigma, and the rule is 2r, and maybe r equals 1 to 10. Now, I don't always have to write this r equals 1 and 10 in there. Often you'll see this written in a slightly different way. It might just be written as 1 and then 10 there, and then the rule 2r. It doesn't always have to start with 1 either. It might be that I'm interested in the 2 times table, but I'm interested in the sum of the terms from the 100th term to the 105th term, or the 110th term even, and that's specified there. So sometimes you might see it written just as simply as that. Sometimes there's an r there in the bottom, r equals 100. Sometimes there's an r at the top. But that's sigma notation, and we'll get used to seeing that as we work more with both arithmetic and geometric sequences and series. So there we go. That's just a nice, gentle introduction to sequences and series. The videos that follow will go into more detail now about the 2 key sorts of sequences that we're interested here for the IB course, and that is arithmetic sequences and arithmetic and geometric sequences. So thank you for watching that. Don't forget to like this video. Don't forget to subscribe to my YouTube channel, IB Maths Intense. And of course, tell your friends I'm here, drop me an email at ibmathsintense@gmail.com if you've got any questions, any queries, or if you spotted any major mistakes that I made along the way. Always glad to hear from you. So enjoy your maths, take care, and tune into the next video, which will be looking at arithmetic sequences and series. Take care.